Good morning to all. Today our topic is about efficiency of washing blast furnace earth. As you must be knowing, this is a very overlooked activity in blast furnace operation, but it is a critically very important aspect of blast furnace operation. So, in subsequent slide, we are going to see the importance of it. So, whether you are an operator, metallurgist, or part of plant management, understanding this concept can help you tackle hearth clogging, improve drainage, and stabilize furnace. So, furnace operation can be further effectively utilized in more better way. And these contexts are most feasible when you are using pulverized coal injection or using low grade raw materials. So it's now time to look into the our title efficiency of washing blast furnace hearth, and this presentation will explore the problems associated with hearth clogging, the symptoms and the warning signs, and how washing methods using a specific material helps restore operational efficiency. So, we are going to look into the aspects, rather, we can say that problem statement. So, modern blast furnaces are under constant pressure due to raw material constraint. The use of low quality iron bearing material, which are backed up by excessive fines in sinter and absence of pellet, contribute to inconsistent burden quality. And on the top of that, the PCI rate exceeding 140 kg per ton of hot metal can lead to a viscous and heterogeneous slag. This disrupts the gas flow and heat distribution in the furnace, resulting in one major issue like choking of hearth or hearth clogging, which ultimately hampers the furnace performance very badly. Now, what are the symptoms of hearth clogging? Here is how you know your hearth is clogging. You'll notice a sudden increase in gas pressure drops, which are a very uh, important symptom. The body in descent slows before tapping. Cost to cost variation in weight, temperature, and composition become a frequent phenomena. Increased wear burning or copper losses may be increased, maybe more quicker. During casting, you will see more graphite and carbon debris. Slack fishing become irregular and unstable. All these are the signs of a compromised hearth. So, pre-emergency signs before a full clog occur, there are warning signs. Significant changes in the hot metal mass and chemistry, and slag become more viscous and its capacity to absorb sulfur increases. Recognizing these early indicators allow us to take corrective action before an emergency develops. So, what is the purpose of washing the hearth? So, why wash the hearth? The purpose is straightforward: to remove accumulated viscous slag, coke particles, and unburned coal. By doing so, we restore the drainage ability of the hearth and re-establish normal thermal and gas dynamic conditions. Now coming to type of washings, are mostly two are prominent, then those are soft preventive washing and target washing. So, what's short preventive washing? This is done continuously, often as a part of normal burdening using material like manganese oxide or high-FeO sinter to prevent slag buildup. Then what is target washing? So target washing used when clear signs of clogging appear. In this case, blank coke is charged first followed by a washing mix to clear out the hearth. So now coming to washing material. What are the washing material? The main washing material that are in mostly use are high-FeO acid sinter forming primary slag. Iron containing briquettes made from plant dust useful for drainage and sustainability. Manganese containing materials to reduce slag viscosity and enhance thermal condition. And here it is pertinent to remember each plays a unique role in restoring furnace health. So you can say high-FeO acid sinter. Let's focus on high-FeO acid sinter. What are its properties, uses, and its effectiveness? As for properties concerned, containing 20% highest FeO produces low viscosity slag that dissolves sticky hard masses, reduces slag softening temperature, aiding drainage. As far uses is concerned, these are basically loaded up to 100 tons per wash, 100 ton per wash, and slag basicity by that reduced to zero point 0.1, which improves its fluidity. The Fe by C ratio is carefully adjusted, and the effectiveness lies with the improved drainage indexes like DMI and DCI, stabilized furnace temperatures, and silicon in hot metal. So containing briquettes. Next, iron containing briquettes. What are its properties? So made from this dusty weights helping reduce environmental load. This is the number one. Not as strong as sinter, but still effective in cleaning. And as for the uses is concerned, these are basically added in 5 ton slot, replacing part of the center. As we know, if we have a higher, then detrimental effect may also occur due to granulometry. These are used for shaft washing, slightly reduce Fe by C ratio to maintain temperature. As for the effectiveness is concerned, we can say that it improves the hearth drainage tremendously and shows smoother operation even with poor center quality, even with its poor center quality. And finally, the manganese containing materials, that is manganese play a triple role in the hearth washing. They are first reduce the slag viscosity, making drainage easier, which is the first important property. It supports the carbon gasification in the lower hearth, and it's improved the desulfurization, enhancing hot metal quality. So we can say that it has got a really huge benefits. As far users is concerned, added in 5 to 20% proportion of the furnace, it can be used. And as for the target is there, 0.25 to 0.35 manganese in hot metal can be planned. As for the effectiveness is concerned, its lower fuel rate consumptions, reduces sulfur and enhance thermal control. Now, as for the washing of shaft and boss wall with acid pellet, another method is using acid pellet to wash the furnace shaft and boss. And the purpose is to form a protective scale layer of solidified slag that seals the lining from the wear. As far the uses is concerned, we can say that they can be charged at the furnace periphery depending on furnace composition. And as for the effectiveness is concerned, it enhances the hearth drainage potential and enhance the hearth drainage potential, and it also maintain the lining hearth over time. So these are one of the effectiveness of washing the shaft. And finally, the conclusion. Let's summarize. Washing the hearth is vital when using PCI, our low grade raw material. Material like high-FeO, sinter or briquette and manganese bearing material clean the hearth and restore furnace functions. Acid pellet plays a support role in wall production. Together, these approaches ensure better drainage, which is most important because drainage takes care of more than 90% problems, and then lower coke consumption and a stable thermal profiles and improved hot metal quality. So we can say that it almost cover the more than 95% of the operation. So key takeaway to wrap up is hearth clogging is a major operational threat. Early detection and washing can prevent serious disruptions. Preventive and target washing must be integrated into furnace practice. So it should not be something different every day or every week. The right combination of the sinter, briquette, manganese material and acid pellet can significantly improve hearth and furnace efficiency. Thank you.